Hello students, welcome back to my YouTube channel Mathematical Lens by Namitha. In this video, we are going to continue with chapter number 7, A Tale of Three Intersecting Lines. And we are going to deal with page number 156 to 159. There is figure it out exercise which is given, right, on page number 159. So, it starts with a question. Will triangle always exist when a set of lengths satisfies inequality? Right? It will always exist. Yes? So the answer is yes. But how can we be sure? Can we be sure about that? So let us understand. Now we can be sure of the existence of a triangle only if we can show that the circles intersect internally. Right? Whenever the triangle's inequality is satisfied. Right? But there are other possibilities where the circles are constructed. So let us visualize and study them. So these are the three situations, right? If we form a circle with given lengths, so the different cases are the first cases, you can see the circle, they touch each other. Case 2 is the circle do not intersect each other. And case 3 is that the circles intersect each other internally, that is at two different points. This is case 3. Now let us understand in which case the triangle will be formed, right? Now while constructing the circles, we need to consider 2 points. First, the length of the base, it should be the longest, right? The longest of the given length, whatever. Suppose it is given as 4, 6 and 8. So the base length will be, this length would be 8 centimeters. That we need to remember. That is point number 1, right? What does point number 2 say? The radii of the circles to be smaller than the two lengths. Means these are the two lengths, the sum of the lengths. The radius of each should be smaller than the two lengths. It cannot be greater, right? So that we'll understand through examples. Let us see further. So now, which of the above mentioned case will lead to the formation of a triangle? Clearly, triangles are formed only when circles intersect each other internally. That is, in the case 3 only the triangle will be formed. So let us understand it a little better in detail about the 2 points, what happens in each case. So if we study the case 1, that is case 1, the circles, they touch each other at a point, only one point. This is case 1. I'll just show you the diagram, case 1. Right, so they are touching each other only at one point. Right, so what happens over here? The sum of the two radii will be equal to AB, or the sum of the two smaller lengths will be equal to the longest length, right? So what will happen over here? Suppose we take, going again and again going back to the diagram so that you understand. This is 3 centimeter, this is 4 centimeter. So 3 plus 4 will be equal to AB, 7 centimeter. Here, in this case, it will be equal, that is 7. Right? It should not be equal. It should be less. It should not be greater. It should not be equal. Let us see case number 2. Right? So here they have shown case number 1. This is 3. This is 4. So the total is 7. Now let us see the second case. Circles do not intersect internally. Now what will happen in this case? The sum of the radii will be less than AB. So again, if I take this 3 and this as 4, so AB will be sum of the two radii, 3 plus 4, if I take that is 7. It will be less than this total length AB. Why? Because this portion is, let's suppose this is 1 centimeter. So that would be 8. Right? It cannot be less. The sum of the two radii cannot be less. So again, the triangle, it will not satisfy the triangle inequality. So triangle will not be formed. Now the third case, circles they intersect each other. Now what is happening over here? So if I take this as 3, this as 4, so 3 plus 4 is 7, right? The sum of the radii is 3 plus 4, 7. But in this case, if you can see that this is included here in 3 as well as 4. So it has to be, AB has to be less than that, right? So what is happening over here? The sum of the two radii is greater than AB, right? AB is composed of one radius and a part of the other, as I showed you, right? So the sum of the two lengths is greater than the longest length. So with this we can say that the triangle will be formed only in case 3. Now can we use this analysis to tell if a triangle exists when the lengths satisfy the triangle inequality? Yes, we can do that. If the given length satisfy the triangle inequality, the sum of the two smaller length is greater than the longest length, which is only in the case 3, where the circles they are intersecting internally and the triangle exists, right? Now, how will the two circles turn out for a set of lengths that do not satisfy the triangle inequality? So that will be case 1 and case 2. So either they touch each other at a point, that is case 1, and either they do not intersect each other, which is case 2, right? So the triangle will be formed only in case 3. So here it is given, frame a complete procedure that can be checked to check the existence of a triangle. So what we do, we take the longest side as the base. This actually I've shown in figure it out exercise of page number 156. The complete procedure, that also you can refer, but I'll just tell you in short. So you can take the longest side as the base, and with the shortest side you form a circle with one of the side, and you form another circle with the second point as a radius, and if they intersect means the triangle will be formed, right? So this is the conclusion, that if a given set of 3 lengths satisfied the triangle inequality, then the triangle exists having those as side lengths. And if the set does not satisfy the triangle inequality, the triangle does not exist. As simple as that. Now we'll do the figure it out exercise. Question number 1, check if a triangle exists for each of the following set of lengths. 1, 100 and 100, like that. There are 4 questions. Question number 2 and question number 3. Let us solve it one by one. Question number 1A. So we use the triangle inequality here to show that whether the triangle will be formed or not. So we check the sides. 1 plus 100 is equal to 101, which is greater than 100, right? So this satisfies. Then again here 2 sides are equal, then we need not do 3 times. We'll do only 2 times. 100 plus 100 is 200, because this will be repeated. It is greater than 1 naturally, right? So all conditions satisfied. Satisfied. Therefore, a triangle exists. With the 3 sides which are given as 100 and 100. Okay. Now we do question number B. In B, the sides are given as 3, 6 and 9. Right, so now we take the same triangle inequality. 3 plus 6 is 9, which is equal to 9. Now this is not greater. So if it is not if it is equal, if it is not greater, then also it does not satisfy the triangle inequality. So we don't need to check the other two, right? So this does not satisfy. Therefore, a triangle does not exist, or it cannot be formed. Fine. This was question number B. Now question number C. The sides are 1, 1 and 5. Okay. So we take 1 plus 1. Always check the first two smaller sides, which is equal to 2. So you can decide in one statement whether it is. So this is less. 2 is less than 5. Right? It has to be greater. So again, here the triangle does not exist. Fine. So this is question number C. Now we go to question number D. Lengths are 5, 10 and 12. Right? So 5 plus 10 is 15, which is greater than 12. Okay, fine. Then 10 plus 12 is 22. It's greater than 15. Not 15, 5. The third side is 5. So this also satisfies. Then we take 5 and 12. So 5 plus 12 is 17. That's greater than 10. So this also satisfies. Right? So as all conditions are satisfied, the triangle exists. Question number 2. Does there exist an equilateral triangle with the sides 50, 50, 50? In general, does there exist an equilateral triangle of any side length? Justify your answer. So first let us check the inequality for the sides 50, 50 and 50. It's an equilateral triangle. Right, so we need to check only once. 50 plus 50 is 100 and it is greater than the third side 50. Right, so it satisfies the inequality. This satisfies the triangle inequality. Therefore, triangle will be formed, right? Can be formed. Right, now they have also asked, like, in general, does there exist an equilateral triangle of any length? Yes, it will exist, but it should be a non-zero number. That is a condition. So if I write the second answer, yes, in general, any set of equal sides which are non-zero, that is important. Because 0, how will you form a triangle with a number 0? Which are non-zero can form an equilateral triangle. You can take other example also and understand it. Right? So justify your answer. So let us, they have asked us to justify. Though we have justified with 50-50, we'll take some other length which is small. So suppose I take 2, 2, 2, right? It's an equilateral triangle. So 2 plus 2 is equal to 4. It's greater than 2. So here also triangle will be formed. So you take any length like 1, 1, 1. So 1 plus 1 will be 2, greater than the third one. Right? So in all the cases, the triangle can be formed. So this is answer number 2. Question number 3. For each of the following given, give at least 5 possible values for the third length. So there exists a triangle having these as side lengths, right? Decimal values could also be chosen, right? So they have given only 2 side length. We have to choose third side length and we have to give 5 possible values. So there are 3 questions based on this. We'll solve them one by one. Here there is one more thing given. See if you can describe all possible length of the third side in each case so that a triangle exists with those side lengths. For example, in case all numbers strictly between 99 and 100 and 1 would be possible. So let us see that. Now here 2 sides are given, 1 and 100. We need to find the third side. Now there is a trick. What you can do, you can find out the sum of the 2 sides given, which is 101, and the difference of 2 sides given, subtract the smaller from the bigger, that is 99, right? So the third side value will be between these two, 99 and 100, right? The third side should always, the value should be between 99 and 101, right? So the possibilities here, one is 100. You can take 100 as the value. But they have asked us 5 possible answers and we can have decimal values as well. So we can take 99.1, 99.2, 99.5, 99.7, any random values you can take. We can take it as 100, can take it as 100.9 maximum, right? So these are the different values which are possible. More than that are possible, but we have written 5 of them. So this is the trick. Whatever the 2 sides are given, add them and subtract them. So the third value will be between these 2 numbers only. So this is question third A. Now we check for B. Similarly, B, in B the values are, the numbers given are 5 and 5. Right? So we apply the same trick. We add the numbers 5 plus 5, that is 10, and 5 minus 5, that is 0. So the value will be between 0 and 10. Don't take 0 and 10. You have to take it between 0 and 10. So the possible values are, so after 0 it is 1, 2, 3, 4, 5, 6, 7, 8, 9. So till 9 you can write any of the signs, 1 to 9. You can write also in decimals, that will also be correct. So this is answer number B. Now in C, the numbers are 3 and 7. So we add 3 plus 7, that is 10. 7 minus 3 is 4. So the value, possible values will be between, should be between 4 and 10 and not 4 and 10. So we can take 5, 6, 7, 8 and 9. So these are the possible values, 5 possible values. Sometimes if you get only 1 as an integer, you can take decimal numbers which fit in between the range, right? So this is the figure it out exercise. We'll continue with this chapter in the next video. Thank you.